Welcome back to iOS Expert. In this video, I'll show you how to level up your unit testing with a custom app and scene delegate. I'll also show you how to refactor an overstuffed view controller to facilitate unit testing. Converter VC is a good candidate to test next because this class lies at the heart of Roman numerals. Unit test coverage of that class's file is already at 44%, but that number is deceptive. The scene delegate initializes and displays a converter VC on every test run, exercising some converter VC code, but no verification of converter VC's functionality is actually performed by unit tests. To get a true reading of actual unit test coverage of converter VC, currently 0%, you must use an alternate scene delegate that doesn't initialize or display converter VC on every test run. To use an alternate scene delegate, you must also use an alternate app delegate. In a production app, using an alternate app delegate for unit testing has another big benefit. The testing app delegate performs no work that is not relevant for unit testing. For example, your production app delegate often invokes an analytics service, which takes time. Your testing app delegate has no need for analytics, so it doesn't connect to an analytics service. This makes unit tests run faster. In light of these benefits, I always use alternate app delegates and scene delegates for unit testing in both coding challenges and production apps. Here is how to implement the alternate app delegate and scene delegate. Currently, the @main annotation marks app delegate as the entry point for the app. But to enable an alternate app delegate entry point used for unit tests, you need to remove this annotation. Do it. You can't build now because there is no entry point for the app. To fix this, create a file in the delegates group called main.swift. By convention, the word main is all lowercase. Give the file these contents, snippet 7. Run the app to ensure that it still works with these modifications. You can now create testing app delegate and testing scene delegate. In the Roman numerals tests group, create a group called delegates. In that group, create a Swift file, not a unit test file, called testing_appdelegate.swift. Give the file these contents, snippet 8. Ignore the build error about testing scene delegate. In that same delegates group, create a Swift file called testing_scenedelegate.swift. Give the file these contents, snippet 9. Ignore the build error about testing root VC. Note that this file, unlike the other scene delegate, doesn't reference converter VC, which means that converter VC won't be initialized and displayed on every test run. Instead, testing scene delegate initializes and displays a testing root VC. The file for that view controller doesn't exist yet, so create a Swift file in the same delegates group called testing_root_vc.swift. Give it these contents, snippet 10. Run all unit tests. Note that testing root VC, not converter VC, is displayed during unit testing. I've slowed down one of the unit tests to make that apparent. Display the unit test coverage report. Total coverage is unfortunately a lot lower now, 43%, but Converter VC is now appropriately and totally uncovered. You can now start unit testing Converter VC, secure in the knowledge that any reported unit test coverage is the result of intentional unit testing, not an artifact of running any unit test. The less a file does, the easier it is to unit test. These two conformances, to UI text field delegate and UI table view data source, complicate testing Converter VC. The next step in the unit testing journey, then, is to refactor those conformances out of Converter VC and test them separately. UI text field delegate is first. I'll first show you what the conformance does. The first function, should change characters in, enables the relevant convert button when the user types some text in the text field. The function also disables the convert button if the user deletes all text in the text field. The function is slightly non-trivial because there are two text fields, and I didn't want to duplicate the conformance. The second function, text field should return, causes the appropriate conversion to happen when the user taps the return key on the virtual keyboard. The conversion performed depends on the identity of the text field, decimal to Roman or Roman to decimal. Putting this conformance in a different object and file is straightforward. The initializer for the object needs three things: a converter view, which owns the relevant buttons and text fields, a closure to run when input on the decimal to Roman text field is finished, and a closure to run when input on the Roman to decimal text field is finished. In the delegates group, create a file called converter_textFieldDelegate.swift. Give the file these contents. Snippet 11. Converter VC needs a few changes to use this new object. In that file, delete the UI text field delegate conformance from the first line of Converter VC. Add snippet 12 just below that. Add this code just below the initialization of the view in load view. Snippet 13. Change the very next line to this. Snippet 14. Delete the two UI text field delegate functions. Run the app to ensure that text views are still working. Here is how to unit test Converter text field delegate. In the second delegates group, create a new unit test file called Converter text field delegate tests. Give the file these contents. Snippet 15. The goal of this class is to unit test two functions, should change characters in, and text field should return. Those functions run on two different text fields, Roman to decimal text field and decimal to Roman text field. The easy approach would be to write four test functions, two each for the two text fields. But this would result in a lot of code duplication. The two functions for testing should change characters in would be identical except for the text fields and buttons they operate on and make assertions about. The two functions for testing text field should return would be identical except for the text fields they operate on and make assertions about. If functions that are supposed to be mostly identical get out of sync, which can happen, bugs can creep into the unit tests. Here is how I prevented duplication in this case. I put the should change characters in logic that doesn't change in a private helper function called private test should change characters in. The parameters for that function includes the things that differ, in particular the text fields and buttons. The prefix private, rather than test, on this function means that it does not get called directly by the unit test runner. I called this helper function twice in a test function, once for each of the two text fields. I then created a private helper function called private test text field should return that has parameters for the things that differ, in particular the text fields. Again, the prefix private rather than test on this function means that it does not get called directly by the unit test runner. I called this helper twice in a test function, once for each of the two text fields. When I pasted the large snippet with elegant non-repetition of code, you might have gotten the impression that this code sprang from my head fully formed, Athena from Zeus style. That did not happen. Instead, I started out with the inelegant solution, saw the repetition, and refactored to eliminate the duplication. I find that this sort of refinement is just part of the unit testing process. Run all tests. Coverage is back up to 59%. The next conformance to factor out of Converter VC is UI Table View Data Source. This conformance powers the results table. Number of rows in section computes the number of rows as the number of elements in the results array. Cell for row at creates result cells based on the contents of the results array. Height for row at, not surprisingly, tells the runtime how tall to make rows. A brief aside. You might wonder why height for row at reaches into converter view for row height, rather than just returning a constant defined in this file. The answer is separation of concerns. Details about a UI, including row height, are more appropriately contained in the definition of a view than of a view controller. A view controller's only jobs, ideally, are to own views and to respond to lifecycle events, like load view. Putting the UI table view data source conformance in a different object and file is also straightforward. The initializer for the object needs only one thing, an array of results. In the delegates group, create a file called converterdatasource.swift. Give the file these contents. Snippet 16. Converter VC needs a few changes to use this new object. In that file, delete the UI table view data source conformance from the first line of Converter VC. Two lines below that, replace the declaration of the results array with this. Snippet 17. Replace the first line of the main initializer with this. Snippet 18. In load view, replace the call to setup table with this. Snippet 19. Delete the 3 UI TableView data source functions. Replace the 8 instances of the bare results array in the file with converter data source.results. Run the app to ensure that the table view is still populating. Unit testing converter data source is straightforward. In the second delegates group, create a new unit test file called converterdatasource.tests. Give the file these contents. Snippet 20. Here is another example of properties in unit test classes. These properties help avoid repetition across test functions. In this case, multiple functions use this data source and index path, so it makes sense to declare and initialize them once. Test number of rows in section just confirms that the number of results returned by the conformance equals the number of results passed to the data source's initializer. Test cell for row@, verifies that the conformance function returns an actual result cell. Here is another XCTest API, XCTFail. Sometimes, something goes wrong in a unit test, and continuing to execute the unit test doesn't make sense. In this case, if getting the cell fails, no tests can be performed on the cell. The XCTFail provides a diagnostic error message about the unit test failure, and the return statement ends execution of the unit test. Test height for row@, verifies that the row height returned by the conformance function is the row height defined in converter view. Run all tests. Unit test coverage is back up to 65%. In this video, I showed you how to spice up your unit tests with a custom app and scene delegate. I also showed you how to refactor an overstuffed view controller to make it testable. In the next video, I'll introduce you to key concepts that undergird a comprehensive unit test suite.